Okay, tell me when you all see my screen. Are you able to see my screen?
Yeah.
Okay, as part of the first session, we wanted to ensure we are covering basic symbols in flowchart. So we covered input, output, parallelograms, rectangle for processing. For decision making, what was the symbol?
Diamond.
Diamond. Good. Then we also use termination, beginning and termination. We use terminal symbols.
Okay.
So these are basic. This is sufficient to depict a common program. Okay. There could be few more like connectors I showed you. If your diagram is growing too much, goes across pages, you can use connectors. And there are few other symbols also are used. I'll just show you what they are. But those are very rarely used and you don't have to worry much. The idea is we use these symbols only to get started. Okay. So for example, sometimes they use a rectangle with a double-sided what do you call border like this. Okay, this is one symbol. I'll tell you where it is used. Whenever you do some database operations or file storage, right? If you're telling collect the database, store it in some or subprocess, there is something called subroutines. Okay, subroutine means you can write a small program which you think you will be using multiple times, right? You can write it as a separate program, and that program you can refer. So I'll give you one example. Let me think. Suppose you are always calculating the tax calculation, right? The other day we had an example of calculating taxes. Wha- What was the logic for tax calculation? We told, let me see, I can open an Excel document and I can explain. So it's easier to follow.
Sir, I can't see the screen. It's only the training cycle screen is
Okay.
visible.
I'll share my complete screen. Okay, tell me when you see my screen. What I was saying is sometimes we use this kind of a symbol. This is called a subroutine. This is called subroutine. In other languages, these are also called as functions or procedures. There are different names for this. Very common name is function. Okay. In a layman term, they call it as subroutine. What is the meaning of subroutine? You have a main program, and you in your main program, for example, you are collecting students' marks the other day, right? Or you were calculating the tax. So we wrote the program to collect, to receive or accept only only one employee's salary, 3 months salary you collected, right? And then we calculated his total taxes. But imagine you have to gather salary for 1,000 employees in an organization. After accepting the individual salary, after entering the individual salary, you want to calculate tax for every employee. So how big your program will become? It will become very big, right?
Yes, sir.
We saw Rabia writing that enter, accept. So it went into so many steps the other day. Let me
Yes,
see,
sir.
I'll bring this example. I think it was this one. Yeah, you can see here. She's telling enter the name, accept the name, enter date of joining, accept date of joining, enter first month salary, accept it, enter second month, accept second month, third, fourth. So this is for only one employee.
Yes,
So
sir.
we told here only we thought of, hey, why to accept 3 times? We can put it like a loop. We can just tell enter. I'll show how I think Sudha had written. Okay, Sudha just multiplied. Maybe I think our example was good. Let me see. I closed it, but let me try to open. We wrote with a slightly different technique. Java, I think this is the one. It is one of this. I think this one. This is another way of writing. So what we are doing is we are making it a little bit more generic. You can write a program like this. This is not a problem. But this is not manageable. And if you have to expand this, you have to collect for, say, all the employees in the organization. So we
Yes,
can't
sir.
keep writing enter for employee number one, gather all this, then again employee number two and gather all this. So it will simply grow into, if you're having 1,000 employees, you have to write these steps 1,000 times.
Yes, sir.
And second, it becomes static kind of a program. If employee increases, for example, right? Today there are 10 employees, and say you wrote the program for 10 times, you're accepting it. What if 5 new employees join the company? So this program will become hard coded. It will not work for 15 employees. If you have written for 10, only 10 it will work. In this example, we have written accepting the salary for 3 months. It will only work for 3 months. Correct, right? Suppose the
Yes, sir.
requirement changes and we tell collect it for 5 months or 6 months. You have to come and then rewrite the program. And whenever you rewrite, you have to retest, and it is not dynamic. So on the other hand, we said we can write it like this. You are seeing my other screen, right? Uh, yeah, you are able to see this screen. See here,
Yes, sir.
what we are doing is we are accepting 3 months salary here, and three we are just giving it in the condition here. So tomorrow, if I have to collect for 6 months, I don't have to change any of the steps. Simply change this number to 6. You see the advantage of this?
Yes, sir.
It's dynamic. Okay. So yeah, I see Uzma also joining, and Romana is there. Okay. So here we try to make it little dynamic by using a loop. Instead of hard coding, we used a loop. Now similarly, suppose for this tax calculation, I know you are using conditions here, but what if tomorrow my tax changes again, or I have to calculate this tax for 10 different employees? First is collect the data for 10, keep calling this for 10. You get the complexity, right? This is for one employee. If I have to collect it for 10, do you think you have to replicate this whole steps 10 times?
Sir.
Right? That is a very crude way of
It's
doing.
lot
And
of
also
time.
every time, lot of time, it's a big code. If you make a mistake here, you correct it here one time. Now you have to do that correction in all the 10 places. And secondly, this will work only for 10 people. Tomorrow, if you have to make it run for 12 people, 2 more employees joined, you cannot make it dynamic. So the idea is wherever you see some kind of repetition patterns, suppose you are collecting for one employee, let me make it for 10, or I'm collecting for three, let me, this many steps, you can copy these steps and create it as a procedure or a subroutine or a function. These are all different
Okay.
names. All the three names are same only. Don't confuse. So what we can do is take the steps, see this many steps, create a small program, a mini program. And that mini program we are calling as a subroutine. We'll call this program as, I think we open this in a, make a copy of this. that is subroutine. See, what we can do is we can call this itself as a subroutine. I'll do like this so it's easy for you. I'll cut this much. Just trying to move it down. Okay, let me keep it like this. Put it to the side, okay, so it's better. This, you're making it like a small subroutine program. We generally use a symbol like this. This is just to tell it is a sub function or a sub routine. We are making this as a mini program basically. You can give some name here. You can call subroutine or function. Okay. To salary, return total salary. So this what it is doing
Total
is just it will calculate total and return back. Okay, I'll show you what I mean. This is a small program, and here I will tell there is always a return the results, return total salary. Total underscore salary it is. Okay, I think I made a mistake. That's okay. And then I'll end. See, what I'm doing is I'm modularizing, or we are breaking one big program into small sub programs. Why we are doing this? This is more manageable, and or you can tell stop. Or basically there's no stop, there is a return usually. But I'm just using these symbols to tell this is a small program. And where is your main program? Our main program will be this one. Let me take this example only, okay? I'll just alter whatever, who is this, our Rabia had prepared. What will happen is, this is my main program on the left side. This is what Rabia had written. And here, we will not write the steps, whatever I'm highlighting. From this point, total, this many steps she had written, right? I will make it and put it in red color. I don't want to use these steps. The reason is this is hard coded. It will run, it will accept for 3 people, 3 months, 3 months salary. So the program will remain like this, accept the employee name, accept the date of joining. And after this point, we will call a subroutine here. Make it black color only. This is the new symbol that we use to call function or a subroutine. Okay, we will tell subroutine. And what is the name of this? We'll give some name for this guy.
Total salary.
Calculate except underscore calculate total salary. Suppose this is my name. Underscore. This is the name I am giving for this subroutine. This will be the name. Okay, this is a small subprogram. This is my main program, but repeatable steps I am putting it in a small subroutine, subprogram basically. And this program I am calling here. Whenever I call this one, internally it's going to. I'll tell you what is the advantage of this. So the advantage is you write this only one time and you are telling, okay, for first employee, call this. This guy will collect all the details and give back the total. And all you have to do is print the total here. Where did we get total salary from? We got it back from here, this place. See here, it will call this guy. This guy will tell, hey, enter your salary, first month salary, second month salary, third month salary. It will go into 3 loops, calculate the total and return back the total here. And you are able to just display that total. Are you with me so far?
Yes, sir.
The advantage is you can call it any number of times, this portion. Because I'm collecting for 1 employee, tomorrow I have to collect this for 10 employees. I told you we have to make this also repeatable, but just to explain the concept, this is for first employee. What you are going to do is you will collect for second employee here. Then one more time, you collect for third employee. Suppose you are collecting for 5 employees, right? My flow will come like this. These steps, you just keep repeating it. One more time here. One more time here. What we did, we reduced so many steps. Do you agree? You are getting the idea?
Yes, sir.
This many steps, instead of this, she had written it right. This we made it like a reusable code, reusable subroutine, reusable method of code. This you simply keep calling this. One time you called, second time you called, third time, fourth time. You can call it as many number of times as you like. Okay, this is subroutines, subprograms. Sometimes you call it as function also. In the Java language, they call it as functions. But in flowchart terminology, we call it as subroutines. Okay, after this, you are going from here. And it's not legible, but just to give you an idea. So you understood what is a subroutine, right?
Yes, sir.
Okay, one symbol. Pretty much there are some file operations. If you want to open a file, write into file. Because see, you want to store, you're collecting all these details. You calculated also, you are displaying the value. But I want to store this for permanent purpose. I want to store the employee name, date of birth. I want to maintain in my computer. Tomorrow, if I want to come and search, I should be able to search using this program. So if I have to store things, there are usually 2 different ways we store. You can create a physical file and store it inside the file, like a notepad file, or we call it as a data file. You can do store with a file, comma separated we tell, comma separated files. You'll learn more about it when you learn the programming. What is important is learning this logic is important. And how do I store the data? How do I read the data from the computer, from the hard disk? Those things and all you learn once you start begin programming it. You can also connect to a database and store it in a database. Okay, database is it is a structured storage. You will learn one database when you learn a programming language. So okay, let me just see. I was talking about different shapes and diagrams used in a flowchart. We have seen, I think, four basic shapes, and this is the fifth one for subroutine. And I wanted to talk about, this symbol is used for begin and end, and this is usually for input and output. Input can be like accepting from the user, reading from a file, right? Or those are all input operations. Reading from a file also becomes an input. You can use different keywords. I saw Adnan teaching about algorithm. So you would have seen he has used different standard words like accept or input, or you can tell read, right? They all mean the same. You're reading from a file. Your input means you're telling, hey, input, get the value, or you're telling accept a value from the user. So you can use different words. It doesn't matter. But when you start using a programming language, the language provide standard set of function names. You have to use the same function name. Like Java is using print. Okay. Um, Likewise, if you use some other programming language, they may use slightly different function name. So don't worry about that. When you run the language, you will get it. Same way for display purposes, you can use the words like display. This is for displaying, printing, print, display, write. All those keywords you can use when you write a program like this. And same way, this symbol is for process, right? This one we told you are calculating total salary here. So, and while calculating, you can use all arithmetic operators: add, multiply, subtract, divide, average. You can use all the words, or if you are comfortable, you start using the symbols also, like plus symbol, minus symbol. It's easy to understand. And after calculating how it stores on the left side, all that you'll learn when you go into a programming language. Okay, if you're not getting this, then you can use English language only. Don't worry about it. See here, now I have just magnified. So we used how many? 1, 2 symbols here, plus and equal to. So what is the precedence? How will it calculate? This is my variable, right? We spoke about variable and constants.
Yes.
So it takes the value from the two variable. They both should be of same type. And depending on the operator, we call this as a operator. If it is a number, it becomes an arithmetic operator. If it is a string, meaning two sentences you have, it will merge the two sentences. We call it as concatenation. There will be functions, there will be operator overloading. Okay. So all those concepts you will learn later. Don't worry. I'm just using some new terminology. But for you, you just understand the operators can be used. You can use sentences for now. When you learn a language, you start using the actual symbols. I'll be giving you some simple examples. Okay. I will give maybe 10 exercises. Very simple, very basic. It will be like get a number, get two numbers, multiply the two numbers, and display the result, print the result. Or you might, I will give one more exercise where you have to get a number, accept a number from the user, add one extra number to that, and display the result. Okay. So like that, I'll give you very basic, simple 3 to 4 examples. And then gradually I will increase the complexity. So that way, the new people who have joined, like Aisha and others, they can also get acquainted with these symbols. So Aisha, did you get a chance to go through the previous recordings? I think Uzma also missed some classes. Both of you got chance to go through our previous recordings? Hello, I cannot hear you. If you are speaking, you are on mute. Uzma,
Yes, sir.
did you go through the previous recordings?
No, sir.
Make sure you go through the previous recordings. Are you getting the concept that we are explaining today? Or is it,
Yes, sir.
how about you, Aisha? I think she is away. Okay, next we will speak about data types. Okay, we also spoke about these different declarations. When you begin a program, usually you declare all the variables. What are variables? Variables are type of data storage elements. Whatever you use in your program, you should tell computer to allocate space, memory, and you give some names, unique names for this. Okay, and you also tell what is the type of data you want to store. It's a number I want to collect, so I will use this total salary as a internal variable. I'll use number of months as an internal variable, number of salary, sorry, total salary or individual salary. Or you want to collect the employee name, right? If you want to collect all the employee names in this example, suppose you want to accept all the employees in an organization. So you don't know how many employees are there. It could be 500, then it may keep growing, company might grow, and your program should be dynamic. So in such situations, you declare a variable and you allocate memory and store it. There are arrays and other concepts. We'll not go into in detail about it. But for now, what you learn is you are doing some calculation here. You're receiving the salary. Salary should be stored somewhere, right? So that is a variable. You're telling computer to, I need a memory space of type number. I will start collecting numbers from the user, and I need one memory to store that number. So variables will remain until the program is running. Once the program stops, your variable also will be freed up or unallocated in your memory. I think I gave you example about how your RAM.
Yes, sir.
You remember this example, right?
Yes, sir.
So
Yesterday.
I said this is your RAM, for example, and I told when you declare this number and you tell I am storing a salary, it will allocate one space. This will be 2 bytes or 4 bytes, depending on the operating system. Okay, don't worry about how many bytes, but just remember that when you declare a variable in your RAM, it has allocated one space to store the whatever you want to store. Okay, salary you are storing, number of months you are storing. What was that? It was called months number. I think we declared like this. So it is going to allocate this space. These are all variables. It is there in the temporary memory. It will remain as long as your program is running. When it starts the program here, right? It will start the program. This is your subroutine. It starts the program. It will allocate all these 3 to 4, 1, 2, 3 things you are telling I want to use 3 things. So 3 memory allocations it will make. Now whatever you accept here, accept the salary, it will be stored in your memory. It will store salary here. It will store total here. It will store number of months here. After accepting, you are doing all these calculations, right? It stores all these things. And once it ends, once the program ends, your memory is also freed up. All these 3 things, it will free it up. It will delete. Everything will be gone. Okay. After ending, you can't tell where is my salary. Display salary, you should write here, right? Suppose you are writing here. what will happen? It will tell the program itself ended. So there is nothing, computer doesn't know anything. Everything is freed up. Only before ending, whatever you write here, it will remember that. So these are all called variables. Okay. Now, sometimes you may want to make use of maybe, what's a good example? You want to calculate the taxes. Taxes will not change, right? Suppose in India, for this year, tax slab is 20%. Tax slab number 1 is equal to 20%. This percentage, I'm just using 20. Suppose your tax slab 2 is 30%. I think it starts with 5% or 10. I don't exactly remember, but basic idea is if you want to store these numbers, for next 2 years, this is not going to change. Government has decided tax slab 1 is 5%, slab 2 is whatever 20, slab 3 is 30%. Now you want to make use of this. If the salary is more than 30 or more than tax slab number 1, then calculate your taxes salary times tax slab percentage. You can make use of this in your formulas below, right? Here, suppose you are doing a tax calculation here only, or you are doing a before returning total. Suppose you are returning the tax. So how do you calculate the tax? If you'll write a condition here, again you'll write this diamond, you'll write the condition. If salary is greater than tax slab 1, it is true, what you'll do, you'll tell, okay, this is tax equal to salary times salary times tax slab 1 divided by 100.
Mm.
You got this right?
Yes, sir.
Come inside basically it will come inside a diamond here because you are doing a if condition. What we are doing, we're making use of this tax slab. Tax slab will not change. So we call them as constants. Okay, throughout your program, this will always be tax slab 1 is 5% only. Tax slab 2 is 20% only. Nobody is going to change. So before declaring this, generally we call it as, usually in a flow chart, you call it as constant, CONST. It's just a way to represent saying that this is not a variable. This is a static number. These are all variables. This one you see salary, you keep on updating here. Salary equal to salary plus something. But in your program, you cannot tell tax slab 1 equal to tax slab plus 5%. You can't change the variable. The constant. Tax slab 1 equal to, if you tell it was 5 above, right? If you tell I change it to 10% or 7%, it will give error. Computer will tell, hey, this is a constant. You're not supposed to change. You cannot allocate or reassign a value. Whatever you have declared on the top, right? This 5, it will always remain. You cannot change this. It will give error like this. But salary, total salary, this you can keep on changing. So where and all, can you think about some places where constants will be useful? Taxes
While calculating
yeah, calculating.
pi constant.
Right. See, for example, we know pi is a very good example. If you are doing any mathematical problems, the value of pi will never change. It's universal, correct? Do you think pi one time will be pi equal to 10 and second time pi is 6, sometime 3.14? It will never change. It's 22 by 7, right? If I'm not wrong, it's 3.14.
Yes.
So such things you can declare here. You will tell constant y equal to 3.14. This will, you will never change this throughout your program. Another example is tax slabs, as I told, or think about you are developing a software and you are selling this software to a company and you are charging them for the number of user licenses. I will tell my program should be used only by 10 users. I'm selling this only for 10 users. More than 10 users should not use. So in such cases, I will define some constants here. I will tell license limit equal to only 10. So every time a user has logged in, I'll keep on incrementing this, or I'll keep a counter to check how many users have logged in, and I'll see is it less than this my allowed limit. This value I will keep it constant. This I cannot change once I declare like this. What will happen in your memory is it will like how it is allocating like this. It will also allocate something called constant number. It will tell tax slab 1. It will put the value as whatever 5% or so. This number it will not let you change. Only in the beginning it will allocate. After that you cannot change it. Your program might run for 1 day, 2 days, 3 days. You will never be able to change. Once you end your program, everything will get released. But until your program runs, this you cannot change. This you can keep on changing. These 3 variables. These are variables. These are constants. Okay, that is the concept I wanted to explain. Data types. We spoke about data types, right? You want to capture or accept numbers, store numbers, use numbers for calculation. You use number, int, long, those kind of different data types are there. Each language gives you different flavors or different variety of numbers you can store. Date time is there, strings are there, characters are there. So these are the basic. Okay, just remember this. You want to accept somebody's name, name is what type. Can somebody else answer apart from, I want some new people to answer. Sudha, I know she knows programming. Other people, can you answer what is the data type you will use if you want to accept employee name? You will declare a variable of type. What is the type? Can somebody attempt? You can raise your hand. Okay, I'll give a simple one. You want to accept somebody's marks, students' marks. What is the data type you will declare? Looks like nobody is interested. Shazia, you want to answer that? Romana, how about you? If you want to accept or collect student marks, you will declare it as what? Number, character, string?
Number, character.
No, you're taking the marks, right? Marks is it a number or marks
This is number.
Yes, sir.
Yes, it's a number. So likewise, if you are accepting somebody's name is what?
Name is
String.
character.
Yes, it's
String.
not one character. It is correct. It's a string.
String.
Yes.
Like, but
it is-
sentence is string and name is a character.
Name is also a string. When you collect only one character, right? Only Y or N or initial, you are just accepting somebody's initial. It is a character. One single thing, if you are accepting, that's a character. You declare like this. Character confirm. Suppose what is the values you will accept in this is Y for yes, N is for no. Okay, it's a single character. But if you are accepting somebody's name, right? Student name. This will be a string. String is a series of characters. It can be alphanumeric, we tell, okay? It can be number or characters. I know people don't use numbers in their name, but string is alphanumeric. You can store both number and also a character. For example, somebody's enrollment number, right? You can tell string enrollment
Yeah,
number.
enrollment number has both alphabets and numbers.
Right. So such places you can use alphanumeric. It is a string only. You for now you just learn a string. When you learn the programming language, you will see slight differences. Character and character arrays. There are different concepts, but these are very fundamental basic things. Same is date. We told date of joining, employee joining date. This is for date. Date and time. Where can you use? Give me one example in a program if you're capturing date and time. Not just date, even the time portion. Suppose you're writing a program for, say, attendance system. You're calculating attendance. What time an employee comes in the office and what time he leaves, how many hours he worked. So wherever you're calculating hours, right, there you will use date and time. There is a data type called time. So you can use this fundamental data types. Date time, actually. Date without time or with time that you can mention. So I think variables, constants, data types, you are familiar. We spoke about conditions, if conditions, and you also saw how to write loops in the using the if condition. Anybody has a question? We saw this example, right, where you're writing a loop. It's a true false. If condition is always returns true and false. Using that, you can make loops. How many parts will be there in a loop? What are the main parts I told the other day? 3 parts. Are you recollecting? Declare, first is declare this, declare the variable, initialize, we call it as initialize. Check the condition. This is the condition. Third is increment it. 3 parts. Whenever you write a loop, initialize, check the condition and enter inside it, and reinstall so that you can exit also. Without these 3 parts, if you write a loop, you will never go out of the loop. Or if you make a mistake in this condition part, you initialize something and your condition is wrong, it will never enter or it will never exit. So you should remember always to increment. Okay, I'll give few examples. I'll give you a few exercises so you can practice this. Okay, today I will probably 5 to 6 different examples I will try to send in the WhatsApp chat. You people can practice. Okay, we saw about loops. I'm just checking the course material. What else I should cover in this session? So loops is very important, okay? Because if you don't write proper conditions, computer will not know, it will go forever. So we are giving this example, right? You want to collect data or you want to calculate salary, total salary or taxes for say 10,000 employees. Any guess how much time computer will take to calculate for 10,000 employees? If I write this loop and I execute, how many minutes, hours, seconds,
Maybe
how much
within
will it
a minute.
Yeah.
It might take a few seconds.
Yes, it will execute in seconds. So that is the computing power that we tell, right? System users nowadays, systems are becoming more faster. So it will execute in milliseconds, I would say, with the new good configuration computers. And if you leave this without proper condition, it will keep on going into millions of cycles. And your computing resources will be exhausted. It will waste basically. And your system will not respond. It will simply keep on executing. And the only way to stop your program will be to shut down or kill that program. Shut down your machine, stop that program. Suppose imagine Microsoft has put a bug and you're not able to say use this Excel, it's not calculating, working properly. Your system will hang, it will not let you use also, because it will be busy in going in that loop. Okay, you may not be able to operate or use for other programs. So you should be careful whenever you write loops. Okay, I think I'll not go into file operations, because file operations is if how to open a file, how to write records, read records. But as a concept level, I'll just probably spend 5 more minutes, and that will give you a good idea. Because end of the day, whatever you are writing, right, all these programs, what is that we are doing? We are collecting some data, we are storing some data, right? After collecting, we have to store also. In these examples, whatever we spoke about, it is collecting, doing some calculation and displaying the results. But it's not storing this permanently in the database or in the system. So there are two ways of storing, I told. One is you can store in a file. So this memory, what I showed, right? This is a RAM, random access memory. So whenever, I think many of you use smartphones. So what do you see when you buy a smartphone? You will see what is the, how much RAM, how much storage is available. Two things you will check, okay? One is the storage. Storage will be huge. It will be in GBs and terabytes nowadays.
Yes, sir.
This is a permanent storage. I'm just giving two different colors. So this is your hard disk, we tell. Hard disk drive, HDD means hard disk drive. They tell storage also. So you tell, I have a 512 GB phone, correct? We tell I have 1 terabyte phone. Which one you have? 14, iPhone 14, what is the latest? Pro Max, I think, the highest one. It's 1 TB. This is the highest one. So this is all, whatever you store, you take photos, everything, right? It goes into this permanent storage. This is even if you shut down, restart your mobile, will you lose your photos? No, right? They will all be stored here. That's the permanent storage. But whatever you use, there is a RAM also. This is much faster, much expensive. This is the most expensive memory. And this is what computer uses, your mobiles, computer, everybody uses. Internal memory we call. And this memory is used only for running the programs. If you store some value here, you take a photo and you store here, right? It will be gone. If you don't store in, move that photo to your hard disk, this photo will be gone. It will not remain forever. Whatever you store here, it will remain. So likewise, when we are collecting all this data is you are working on this memory. Okay, you're getting the idea, right? You're collecting employee name, enter employee name, you're telling employee age, you're gathering all these details. And once you end your program, this is all gone. You just calculate, store, not store, you just accept, calculate, run, display. Once you end the program, it is gone. If you want to store permanently, you have to store it in the hard disk. So it will open one file. File name is equal to some name. You'll tell employee salary details. This is the name of my file. And this file, I will store three things. What and all? Employee name, age, salary 1, first month salary, salary 2, salary 3. Total salary, if you want, you can store it. Tax, applicable tax. Suppose you have to collect for 1,000 employees, right? And you want to store also. You will tell open one file, create one file. File will have this many elements and start accepting it. First is, for example, Sudha, whatever age, some salary like this. Then we'll tell Romana. You can tell open the file. There are few commands you will, when you are writing this flowchart, you can use this subroutine also to indicate it's a file operation. We will tell open a file, store this record with all these values. So there are few functions that we use, file operations we tell. Don't worry much about it, but just have a idea, okay, that we can store the values also. So when you write a flowchart, you can use this kind of symbol. Open a file, you will use this symbol, and it will read a record, write a record. Same this symbol, read record, write record. So it will loop through the file until the end of the file. See, this is my file, right? And suppose I have collected data for 1,000 employees. I keep collecting and store it here. Open the file, store the record. Open the file, store the record. We tell write is the function. Write record, write record, write record. And for reading, what you tell, open this file, read this, read record, first record, second record. There are different techniques, okay? Sequential read, random read, indexing. So don't worry all about those things, but just have an idea that you can do all these file operations. Okay, your file will look something like this in memory. It will be allocated. That is one thing I wanted to cover. So maybe in tomorrow's session, we'll talk a little bit about more about subroutines. I'll give some more examples for subroutine. And a little bit about file operations, how to open a file, write a report, because after doing all the collection of data, you also generate some reports. So usually a program is collecting of data or generating some reports, generating some printouts. That is all most of the programs are about. What else I can cover? So if you practice this programs, today is Tuesday, right? Today is Tuesday. Okay. So oh, okay. Yeah, sorry. It's Wednesday for you guys.
Okay.
So 2 more days, Thursday, Friday, I'll give you more exercises. Practice them. These are the main basic concepts. And maybe we'll spend a little bit time on algorithms tomorrow. I know Adnan is also teaching that. I showed you one example, but we didn't spend much time on algorithms. Same steps, whatever you're writing with flowchart, we write it in English language. Yesterday we discussed, we'll spend more time on that algorithms. Once you are comfortable with these things, right? Basic algorithm writing and flowchart, you are prepared, you are ready to get into programming. It is programming is same concept, it's only thing you'll use some standard terminologies, standard vocabulary, standard words. Whatever a language can understand, you'll use the same words. Okay, but the concepts, whatever you have learned so far, I think will help you get started. Any questions? I can spend 2 minutes. Anybody has a question or you want something to be recapped, reiterated? Any concept which is not clear? I see some new participants, Rabia. So I'll take your silence as a no, and we can disperse for today. And we'll meet again tomorrow.
Okay, sir.
Thank you.
Thank you.
Thank you, sir.
Bye.